How fast would you have to throw a baseball to make it go around the world and come back? Stick around for the mind-blowing answer. Alright, imagine this. You're standing on solid ground, gripping a baseball, and you wonder, what if I threw this thing so fast that it didn't just land in the outfield, but actually wrapped around the entire planet and came right back to me? A totally normal thought, obviously. Now, if you throw a 105-mile-per-hour fastball, how far does it go before hitting the ground? Well, thanks to physics, we know that gravity pulls everything downward at 9.81 meters per second squared, and from a standard pitching height of 6 feet, the ball will hit the ground in 0.61 seconds. In that time, a 105-mile-per-hour pitch would travel 94 feet, which is great for striking someone out, but not enough to loop around the planet. So, how fast would you actually need to throw a baseball for it to travel around the world and come back to you without hitting the ground? First, we need to clear all obstacles, meaning the baseball can't hit any trees, buildings, or mountains on its way around. The tallest natural obstacle on Earth is Mount Everest, which stands at 29,032 feet, 8,849 meters. To make sure our baseball doesn't clip the top of anything, let's round that up to 30,000 feet, 9,144 meters. Since we're starting from ground level, the baseball needs to be thrown with enough upward velocity to reach 30,000 feet before gravity starts pulling it back down. To figure out how fast that needs to be, we use a physics equation that tells us how fast something must be moving to reach a certain height before stopping and falling. Here's how it works in simple terms. First, we need to figure out how fast the baseball needs to move upward so that it reaches 30,000 feet before gravity pulls it back down. Gravity constantly slows the baseball down as it rises, so we need to calculate the exact speed needed to fight against gravity just long enough to reach the right height before the ball starts falling again. When we run the numbers, we find that the baseball needs to be moving upward at about 948 miles per hour to reach that height. Now that the baseball is high enough to avoid obstacles, we still need it to travel forward fast enough to keep falling at the same rate that the Earth curves away. This speed is called orbital velocity, which at 30,000 feet is about 17,300 miles per hour. Since we're throwing the ball at an angle, the total speed required is the combination of the vertical speed, 948 miles per hour, and the horizontal speed, 17,300 miles per hour. To find out what the overall speed needs to be, we use a math rule that helps us combine two different types of motion into one total motion. Here's how it works in words. First, take the forward speed and multiply it by itself. Then take the upward speed and multiply it by itself. Add those two results together. Finally, take the square root of that sum to find the actual speed you'd need to throw the baseball. When we do that, we find that the total speed you'd need to throw the baseball is 17,326 miles per hour at just the right upward angle. To throw a baseball from ground level and have it circle the Earth and land right back in your hand without hitting the ground, buildings, or mountains, you'd need to throw it at 17,326 miles per hour at just the right upward angle to reach 30,000 feet before leveling off. At that speed, the baseball would make a full lap around the planet in about 85 minutes before returning to your glove, assuming you can even see it coming at that point. So unless you've got an arm stronger than a rocket engine, this one's probably off the table. But hey, next time you throw a baseball, just remember, you're only 17,221 miles per hour away from making history. Follow for more ridiculous physics and let me know in the comments. What's the fastest you've ever thrown something?